Good morning, dear students. My name is Ferhan Mazher, and today is 16th January 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. This is Cambridge O Levels Physics. Today, we have set our hearts to solve a theory paper. We call it paper 2. We have selected May-June 2017 2-2 paper. This theory paper belongs from the zone 2, or you can call it variant 2. In this session, in this video, we will be solving the section A of this paper. The section A is from question number 1 to question number 8. The section B of this paper, we will solve in another video. So let's start today's paper. And the first so you can see that we have selected May-June 2017 2-2 paper. Theory paper, the time allowed is 1 hour 45 minutes. Today we are going to solve the section A of this paper. Okay. A car accelerates from rest in a straight line. During the first 14 seconds, the acceleration is uniform and the car reaches a speed of 25 meters per second. Calculate the acceleration of the car. You see, the initial velocity is 0 because the car started from rest. The final velocity is 25 meters per second, and this change in the velocity took place in 14 seconds. So very easily we can calculate the acceleration. Let me show you. So the initial velocity is 0, the final velocity is 25 meters per second, the time is 14 seconds, acceleration is question. The formula for the acceleration is v minus u divided by t. So 25 minus 0 divided by 14. So please enter these values in your calculator. 25 minus 0 equals to divided by 14 equals to, and it will give you a value of 1.786. And when you round it off, it will be 1.8 meter per second square. So this is how you will calculate the acceleration of this car. Okay, so let's move to the next part. He says, after the first 14 seconds, the speed of the car continues to increase, but the acceleration decreases from 70 seconds to 80 seconds. After the start, the car moves at a constant speed of 55 meters per second. On the figure 1.1, draw a possible speed time graph for the car. It's a 2-mark question, so we have to complete the speed time graph. On the y-axis, the speed is represented. On the x-axis, the time is represented. And I can tell you, in the first 14 seconds, the speed attained by the car is 25 meters per second. And then from 20 to 70, it will attain a speed of 55 meters per second. And then from 70 to 80, the car will move at a constant speed. So let me show you how this is represented on a graph. And here we go. So here you can see I have shown this is the speed. Here we have time. So in the first 14 seconds, so here the 14, this number is 14 basically. So each small square here is representing 2 seconds. So this is 14, and in two small squares, one small square represents 2 on the y-axis also. So 25 will be here. So you can see here, this is the straight line. From 25 to 70 till this point, the speed attained on the 72nd is 55, which is here. So I will join this with a curve. Why I'm joining it with a curve? Because in the question statement, they told us that the acceleration was decreasing. The speed was increasing, but the value of the acceleration was decreasing. So the slope of this speed time graph is equal to the acceleration, because the slope is because the acceleration is gradually decreasing. That's why I will draw a curve here, and the slope of the curve is gradually decreasing. Then from 70 to 80, the speed remained constant, and the speed was 55. So that's why I have drawn here a horizontal line which shows that the speed is constant. Okay. So let's move to the next part. He says, at a later time, the driver applies the brakes to stop. He is wearing a seat belt and slows down in his seat. A bag on the seat next to him slides forwards across the seat towards the front of the car. Using ideas about the forces acting, explain why the driver slows down but the bag slides forward. You see, when the brakes are applied, the bag and the driver both have inertia in them. So they want to continue their motion in the forward direction. You see, the driver is wearing a seat belt, so the seat belt will provide a backward force. So the driver will be stopped by the force applied on him by the seat belt. So, but the bag is sitting on the seat next to him. So because the bag does not have a seat belt around it, so the bag has only the friction between the bottom of the bag and the seat, and that friction is not enough to stop the bag from moving in the forward direction due to its inertia. So it's a 3-mark question. Let me show you my answer. And okay, so here we go. When brakes are applied, both driver and bag, due to inertia, continues their forward motion. Driver experience, this word is drive, not drive, driver. So driver experience a backward force due to the seat belt and is stopped in forward motion. Bag, on the other hand, experience backward force due to the friction between bag and the seat. Friction is not enough, so bag moves forward. So it's a 3-mark question, very important. This word is not drive, this word is driver. Let me write here so I can, this word is driver, okay? So, oops. So we will keep this change. Okay, so I hope you understand my answer. So the question number 1 is done. So let's have a look at the marking scheme. So this is the marking scheme, and here we go. Question number 1's marking scheme is showing up on your screen. What you can do, pause this video and have a look at the marking scheme. Take your time, read this marking scheme, check every answer which we have given to make sure that our answers are correct and they are according to the Cambridge marking scheme. Okay, so let's move to the next part, and the next part coming up on your screen. A swing is made by tying rope loosely to the branch of a tree, as shown in the figure 2.1. A child swings backwards and forwards several times, starting at the highest point A. Explain how another child can obtain an accurate measurement of the time for one complete swing. Okay, so this is the swing, and in the complete swing, you see from A to C and back to A, that will be the complete swing. So what you can do when she has started swinging, what you can do, let her have 2, 3, 4 swings. When her swings become smooth, then what you can do, when she is in the middle position, in this mean position, start counting, start a stopwatch. Okay, so then time 5 swings. Okay, so on the stopwatch, note down how much time it takes to complete 5 swings. And I'm saying that when she will be in the mean position, that is position B, then start the stopwatch. And when after 5 complete swings, stop the stopwatch. So you have the time for 5 swings, then divide that time with 5, and that will give you the time for 1 swing. Okay. So it's a 2-mark question. Hopefully you understand. And we can also do another good thing, that we can put some mark on the ground to locate the position of this mean position. On the ground, put some kind of mark. Okay, so let me show you my answer. After few swings, when swing is at position B, she starts stopwatch. Time for 5 swings is noted. She divide the time by 5. It will give you time for 1 swing. Hopefully you understand. Okay, so let's move to the next part. The next part is of 2 marks. When the child moves from A to B, she falls a vertical distance of 0.60 meter. She loses 240 joules of gravitational potential energy. The gravitational field strength G is 10 Newton per kg. Calculate the mass of the child. Okay, so we know the loss in the potential energy, gravitational potential energy. That's 240 joules, and I know the vertical distance which she moved downward, that is 0.60 meter. I know the G value, so a mass can be calculated. You know the loss in the gravitational potential energy is mgh. So I can find the value of the m. Let me show you the work done. This numerical I have solved. Let me show you. Okay, so the potential energy is equals to mgh. The potential energy value is 240 joules. M is question, G is 10, H is 0.60. So if when I make the M alone on the one side, so you will have 240 into divided by 6. When you multiply 10 with 0.6, it becomes 6. So 240 divided by 6, that's 40 kg. So it means that the mass of that girl is 40 kg. Okay, so suggest 2 reasons why her kinetic energy at B is not equal to 240 joules. So the potential energy here, and when she reaches here, so its potential energy which she has lost do not convert all the potential energy which she has at the point A do not convert into the kinetic energy. There are some reasons, because when the girl is swinging, she experiences air friction. So when she overcome the air friction, energy will be converted into heat, which will be lost to the surrounding. Another thing is that here the knot of the rope and the branch of the tree, they will have friction with each other, and so when you overcome that friction, so the energy will be converted into the heat energy, which will be lost to the surrounding. So that's why the energy lost, the potential energy which is lost, that not all the potential energy converts into the kinetic. Some of the energy has been converted into heat and is lost to the surrounding. So that's why the kinetic energy which she gains at the point B, or which she has at the point B, is not equals to the gravitational potential energy which she has at point A. So it's a 2 mark question. Okay, so let me show you my answer. And okay, so air resistance is present, so some energy is converted to heat when air resistance is overcome. So friction between knot of the rope and branch of tree, when the friction is overcome, energy converted into heat. Energy is, when energy is overcome, I wrote overcome, don't say overcome. We don't have overcome, so this is not there. Okay, this is not there. When energy, when the friction is overcome, energy converts into heat. Hopefully you understand. And let's go. So I hope you understand this question. The question number 2 is done. So let's see. Okay, so the marking scheme of the marking scheme for the question number 2 is showing up on your screen. You can you can pause this video and read this marking scheme. You can take your time. One important thing, that when I told you that at the point B on the ground, put some marks so that it's become easy for you to decide that the girl is on its mean position during her swing. So those marks which you put on the ground, that is known as fiducial marks. FIDUCIAL, fiducial mark. It's very important word, remember. The marks which you put on the ground to locate some position, that is called fiducial marks. Okay, so that's question. That was question number. That was question number 2. So let's move to the next part. Okay, figure 3.1 shows the brake pedal of a car which is connected to a brake cylinder. So here you can see, here we have the pivot, here we have piston, and here we have the brake pedal. So the distance of the brake pedal from the pivot is 22 centimeters, and the distance of this piston from the pivot is 4 centimeter. The force produced in the piston is 80 Newton. The brake is pressed with the force F. The force produces a moment about the pivot. Pressing the brake causes a force of 80 Newton to act on the piston. Define the term moment. You know, the moment is the turning effect of a force, and the moment is actually the product of the force applied and the perpendicular distance between the line of action of the force and the pivot. So it's a 2-mark question. Let me show you how I defined it. It's a very important thing because it's a definition and you should never forget it. Moment is the product of, product means multiply. Moment is the product of force applied and perpendicular distance between the line of action of force and the pivot. Never forget this definition. It's a 2-mark definition. Okay, so here we go. The next part is, he says calculate the force F applied on the brake pedal. It's a 2 marks numerical. So you can see here you applied the force. Its distance from the pivot is 22 centimeter. Here the force produced on the piston is 80 Newton, and its distance from the pivot is 4 centimeter. Because both of these forces, because at both these points, sorry, the moment produced will be same. So the moment produced here, and the moment produced here will be same because this is the same body. So F multiplied 22 centimeter will be equals to 80 Newton multiplied 4 centimeter. And you can find the F value is a 2 marks numerical. Let me show you my answer. Okay. So F1 D1 equals to F2 D2. F1 multiplied 22 equals to 80 multiplied 4. F1 will be equals to 80 multiplied 4 divided by 22. Just enter these values on the calculator. You will get 14.5 Newton. When you round it off, it will be 15 Newton. Hopefully you understand. Okay, so let's move to the next part. And the next part, he says, the cross-sectional area of the piston is 0.0012 meters square. Calculate the pressure exerted by the brake piston on the fluid. So they are talking about this. Here the force applied is 80 Newton and the area is 0.0012 meters square. And they want us to find out the pressure. So I can easily find out the pressure, and let me show you, the formula for the pressure is force divided by area. So pressure is equals to force divided by area. So P is equals to 80 divided by 0.0012. So meter square. So 80 Newton divided by 0.0012 Newton. And when you enter this value into your calculator, you will get the answer 66666.67 Pascal. So when I write it in the standard form, it will be 6.7 x⁴ Pascal. Hopefully you understand. So we are done with the question number 3. So let's have a look at the marking scheme of the question number 3. So my dear students, the marking scheme for the question number 3 is showing up on your screen, and it's very important to check your answers with the marking scheme. Compare your answers with the marking scheme. Hopefully you have read this. Okay, so I have already checked my answers with the marking scheme. So let's move to the next part. Okay, so here we go. He says figure 4.1 shows apparatus used to measure the specific heat capacity of a metal. So here you can see we have a block of metal. We have drilled 2 holes in the metal block. In one of the holes, we have put electric heater, and in the other hole, we have put thermometer. So he says the electric heater is switched on and supplies 17,000 joules of thermal energy to the block of the metal. The temperature of the metal rises from 16 degrees centigrade to 38 degrees centigrade. The mass of the block of the metal is 850 gram. No energy is lost from the metal. The first question is calculate the specific heat capacity of the metal. So you remember that formula, very famous formula, whenever the temperature change takes place, we use the formula heat is equals to mc delta theta. So we have to find out the value of the C, which is specific heat capacity of the metal. The rest of the numbers are given. So let me show you my written answer. So here we go. Heat is equals to mc delta theta. Heat is 17,000 joules. Mass is 850 gram. C is specific heat capacity and is question. Delta theta means change in the temperature. And that will be 38 minus 16. So 850 multiply 22 into C. So when you make the C alone, and that the things 850 and the 22, which is change in the temperature, will go on the other side and it will divide there. So you will have 17,000 divided by 850 divided by 22. Enter these values like this in the calculator and you will get the answer 0.009 joules per gram per degree centigrade. So the specific heat capacity, small c, is 0.91 joules per gram per degree centigrade. Hopefully you understand. Okay, so let's move to the next part. The next part is, he says, calculate the heat capacity of the block of the metal. In the A part, we have calculated the specific heat capacity of the metal. And in the B part, now they are asking us to find out the heat capacity of the metal. The formula for the heat capacity is heat divided by change in temperature. So change in temperature is from 38, it's 22 degrees centigrade, and the amount of heat used is 17,000 joules. So very easily I can find out that. So the heat capacity will be, heat capacity is equals to heat divided by change in the temperature. So 17,000 joules divided by 22 degrees centigrade. So 772.7 joules per degree centigrade will be the answer. Hopefully you understand. Okay, so that was question number 4 and its B part. Okay, so now move to the next part. He says, explain how thermal energy heat is conducted through the metal. You see, through the metal, the conduction takes place by 2 methods. One method is the molecules vibrate. They remain in their fixed position, but they start vibrating vigorously. So their amplitude of vibration increases. So they collide with the neighboring molecules and they make the neighboring molecules vibrate vigorously. In this way, by the vibration of the molecules, the energy is transferred from one hot end to the cold end. Another method of the thermal energy transferred through the metal, or how the conduction is done, is by the free electrons. The metals have free electrons in them and they can flow in the body of the metal. So the free electrons which are at the hot end, they absorb the thermal energy and they flow from the hot end to the cold end. When they reach on the cold end, the free electrons collide with the atoms of the metal there and they make them vibrate vigorously. In this way, the heat is transferred through the free electrons from hot end to the cold end. And we call this process specific free electron diffusion. This process is called free electron diffusion. Let me show you my written answer. I have written this answer also. So heat is conducted through metal by the vibrations of the metal molecules and free electron diffusion. Okay, so that was the question number 4 and its C part. And so the question number 4 is completed. So let's have a look at the marking scheme of the question number 4. So my dear students, the marking scheme of the question number 4 is showing up on your screen. You can pause the video, take your time, read the marking scheme for the question number 4. And I have already done this. So let's move to the next question. He says, when a sample of a solid is heated, it becomes a liquid and eventually becomes a gas. Figure 5.1 shows the arrangement of the molecules in the solid. In the space below, draw the arrangement of molecules in the liquid. So when you show the molecules of the liquid, they should be moving randomly. Some of them should be moving in the clusters, and the arrangement should not be regular. So let me show you. The intermolecular spaces should increase. I have tried to draw this diagram and here you go. You can see the molecules, some of the molecules are moving in cluster, they are moving randomly, they are not regular pattern, they are not in their fixed positions. Intermolecular spaces has become larger. So this is how you represent the liquid molecules. Okay, so it was a 1 mark question. The next question coming up on your screen is complete the table B part. Complete the table by describing the motion of the molecules in the solid, liquid, and gas. So that we have to actually describe what is the motion, how is the motion of the molecules in the solids, liquids, and gases. You know, in the solids, the molecules vibrate only, they remain in their fixed positions, and they vibrate about their fixed positions. In the liquid, the molecules of the liquid, they move in the clusters, they slide each other, and they have a little more intermolecular forces in them as compared to the solid. In the gases, the molecules are moving at a high speed, and they are moving randomly in all directions, and they do not have that much intermolecular forces between them. Okay, so let me show you my answer and then my written answer. So solid molecules vibrate about their fixed position. Liquids molecules slide over each other and move in clusters. This word is in clusters. Okay, instead of saying is, it's in clusters. In clusters throughout the liquid. And gaseous molecules move randomly in all directions throughout container. The molecules move randomly in all directions throughout container, and the molecules also have high speed in the case of the in the case of the gases. So let's move to the next part. So that was question number 5 and B part, and then we have the question number 5 and C part. He says, suggest why a gas is able to fill a container, but a solid has a fixed shape. You know, the gas, its molecules have large intermolecular spaces. They have very slow intermolecular, the intermolecular forces are negligible, and they are moving randomly at very high speed. So what happens? They can fill a container. On the other hand, the solid, its molecules are on their in a fixed position, and they are not moving. They are actually vibrating about their fixed positions. The intermolecular spaces are very small, and the molecules have very strong intermolecular forces, so they cannot fill they have their own fixed shape. So let me show you my answer. Okay. So gas molecules have weak intermolecular forces as compared to solids. Gas molecules have higher kinetic energy as compared to solids. So that's why what they do, they occupy the container they are given. So that was question number 5C part, and I think the question is over. The question 5 is completed. So let's have a look at the marking scheme. It's very important. It's very important to check your answers with the marking scheme. So the marking scheme of the question number 5 is showing up on your screen. You can pause the video and take your time, read this marking scheme very carefully, check my answers and compare them with the marking scheme. Check also your answers. If you have some book which has the answers like red spot, make sure you check each answer with the marking scheme. It's a very important practice. So this is the question number 5, and let's move to the next part. We will be going to the question number 6. Explain the difference between a longitudinal wave and a transverse wave. You may draw a diagram if you wish to help your explanation. Okay. So, in the longitudinal waves has compressions and rarefactions, whereas the transverse waves have crust and trough. In the longitudinal waves, the particles of the medium vibrate parallel to the direction of the wave, whereas in the transverse wave, the particles of the medium vibrate perpendicular to the direction of the wave. So let me show you my answer. I have tried to write this answer. Okay, so here you can see here I've tried to show a longitudinal wave in Slinky. So compressions, rarefactions, compressions, rarefactions, compressions, rarefactions, compressions, rarefactions. So this is longitudinal wave. And here we have shown a water wave, which is a good example of the transverse wave. It has crust and trough, crust and trough. So this is the mean position of the wave. In longitudinal waves, the particles of the medium vibrate parallel to the direction of the wave. In transverse waves, the particles of the medium vibrate perpendicular to the direction of the wave. So this is the answer. Another difference you can write is that the longitudinal waves comprises of compressions and rarefactions, whereas the transverse waves comprises of the crust and trough. So this was question number 6A part. Okay, so let's move to the next part. Okay, he says a sound wave has a frequency of 3.8 kilohertz and a speed of 330 meter per second. Calculate the wavelength of the speed. You know the formula, famous wave equation, V equals to F lambda. Lambda is the wavelength. V equals to F lambda. So if you make the lambda alone, it will be V divided by the F. So very easily I can find. The only problem here is this frequency is 3 kilohertz. In that formula, the frequency is never entered as kilohertz. It's always entered as hertz. So I will multiply 3.8 with 1000. It will become 3800 hertz. So let me show you my answer. It's a 2 marks numerical. So, and it's very easy. V equals to F lambda. Lambda is the question here. V equals to F lambda. Lambda is equals to V divided by F. 330 divided by 3800. So on the calculator, when you enter these values, you get 0.087 meter multiplied with the 100, and you will get the answer in the centimeters. 8.7 centimeter will be the wavelength. Hopefully you understand this numerical. Okay, so let's move to the next part. And a different sound has a frequency of 3.8 hertz. State and explain whether a human with the normal hearing is able to hear this sound. You see, the normal human, its audible frequency range is from 20 hertz to 20,000 hertz. So 3.8 hertz is less than the lower limit of the audible frequency range. So the human will not be able to hear this sound. So let's check my answers. I have written this answer. Okay, so here we go. No, the human will not be able to hear sound of the frequency 3.8 hertz. The reason is the human can hear sound of frequency from 20 hertz to 20,000 hertz. So it's out of the audible frequency range. So the humans will not be able to hear this sound. Okay, so let's move to the next part. The next is the question number 7. So we are done with the question number 6. So let's have a look at the marking scheme. Okay, so the marking scheme of the question number 6 is showing up on your screen. You can pause the video and take your time with this marking scheme. And I have already checked my answers. And when I wrote the answers, I confirmed, check them with the marking scheme. So it's very, very important habit to check your answer, compare your answer, your teacher's answer, the red spots answers with the marking scheme. This is the habit which will actually polish your answers. So let's move to the next question. That was question number 6. Okay, so figure 7.1 shows parts of a DC electric motor. So here you have the North Pole, here you have the South Pole, here is the coil A, B, C, D. Here we have connection X and Y. This is the axis around which about which the coil will rotate. A coil of wire A, B, C, D is placed between the poles of a magnet, and X and Y are connected to a commutator and a battery. So here we always connect the split ring commutator with this mode in the motor. So he says state why there is a force on the side AB of the coil. You see, this AB is a current carrying conductor which is placed perpendicular to the magnetic field. magnetic field is going from north to south, the current will be going from either A to B or from B to A. So the AB is the current carrying conductor placed perpendicular to the magnetic field. So according to the left hand rule, I can predict the direction of the force experienced by the side AB. It's a 1 mark question. So let me show you my answer. I have written this answer and here we go. So AB is a current carrying conductor placed perpendicular to the magnetic field. So it will experience a force. Direction of this force can be found by using left hand rule. Hopefully you understand this question. Okay. So let's move to the next question, A second part. He said, describe how the commutator keeps the coil rotating in the one direction. You see, this is the function of the commutator. When the coil during its rotation becomes vertical, the direction of the current in the AB and the CD side, that is reversed by the commutator. So by reversing the direction of the current, it makes sure that the force acting on the side AB and the CD also reverses. And this helps to keep the coil continuously rotating in the same direction. A very technical answer, and you should never forget this answer, because this question has been asked frequently in the paper, that what is the function of the commutator. So commutator reverses the direction of the current in the coil when the coil is in vertical position during rotation. This reverses the direction of the force acting on the AB and CD, which makes the coil rotate in the same direction continuously. Hopefully you understand. Okay, so let's go to the next part. He says, the current in the motor is 2 ampere and the battery has an electromotive force of 12 volt. In a time of 8 seconds, the motor does 140 joule of work. Calculate the energy supplied to the motor in the 8 seconds. You know the electric energy. Energy is IVT. The amount of electric energy is IVT. Very simple, straightforward formula. So energy is equals to IVT. So I is 2 amperes, V is 12 volt, and the time is 8 seconds. So the answer you get is 192 joules. 192 joules. So let's check what's the next part of the question. So the B second part, he says, find the efficiency of the motor. You know, the formula for the efficiency of the motor is useful output energy divided by input energy multiply 100. Useful output energy is the work done by the motor, that's 140 joules. Input energy is, we just calculated in the upper part, 192 joules, multiply 100. So when you enter these values like this in the calculator, the answer you get is 72.92%, which is 73%. Hopefully you understand this numerical, very famous, frequently asked concept. Okay, so let's move to the next part. So my dear students, we are done with the question number 7. Okay, so the marking scheme for the question number 7 is showing up on your screen. Pause the video, take your time, read this marking scheme carefully. It's very important habit to always check your answers, compare your answers with the marking scheme. It will polish your answering skills for the Cambridge exam. So that's the question number 7. So let's move to the next part. The next part coming up on your screen is question number 8. He says figure 8.1 shows charges on a rod and on a cloth. State how the figure 8.1 shows that the rod and the cloth are uncharged. If you look at here carefully, if you count the negatives here, so for example, 1, 2, 3, 4, 5, there are 5 negatives, 1, 2, 3, 4, 5, 5 positive. So on the rod, the negative charge and the positive charge are equal in amount to each other. So the rod is neutral. In the same way, if you look at the cloth, the negative and the positive, if you count the negatives and the positives, they are equal to each other. So it means that the negative charge and the positive charge, amount of the negative charge and amount of the positive charge on the cloth is equals to each other. So they will cancel out each other's effect. So the cloth as a whole will be uncharged. It will be neutral. It's a 1-mark question. So let me show you my answer. Okay, so the question number 8, amount of positive and negative charges is equals to each other on rod and also on the cloth. So that's why they both are uncharged. They both are neutral. Hopefully you understand. Okay, so that was one part. So B, the plastic, question number 8 and B part, the plastic rod becomes negatively charged when rubbed with the cloth. So the rod becomes negatively charged. Describe what happens to the charges on the rod and on the cloth during the charging process. So when you rub them with each other, so see what happened, the electrons from the cloth has transferred to the rod. So the rod will become negative and the cloth which has lost electrons will become positively charged. So question number B and this. Okay, so let's have a look at the answer. So electrons are transferred from cloth to rod. So the rod becomes negatively charged and cloth becomes positively charged. Hopefully you understand. Okay, so here we go. He says a 2-mark question. He says, describe a simple experiment to show that the plastic rod is charged. You may draw a diagram if you wish. You see, if the rod is charged, I will take an electroscope which is uncharged. And you know, in the electroscope, gold leaf electroscope, it has 2 gold leaves and they are together at the bottom of the electroscope. And when you bring a charged body near the cap of the electroscope, due to the charged body, what will happen? The gold leaves will open up. They will move away from each other. So if the rod is charged, you bring it near an uncharged electroscope. And if the gold leaves move away from each other, that will show that the rod is charged. It has some kind of charge. For example, I have shown this. Okay. So here you can see we have shown a gold leaf electroscope. So you can see this is the brass plate, this is the rod, and here these are the 2 gold leaves. And when you bring the charged body near this top plate, so due to that, this also becomes charged, and these gold leaves, when they become charged, and they will get same charge on each of them, so they will repel each other and the gold leaves will open. So you will visually you will be able to see that when you bring the charged rod near the top of the electroscope, the gold leaves, they will open up like this. So that shows that the rod is charged. So my answer is bring the rod near the electroscope, which is not charged. The electroscope is not charged. Gold leaves will open. This shows rod is charged. If the gold leaves will open, this will show that the charge is rod. So we are done, and hopefully you understand. Let me show you first of all the marking scheme for the question number 8. So my dear students, the marking scheme for the question number 8 is showing up on your screen. You can pause the video and you can take your time, read it carefully, check each answer, compare each answer with the marking scheme. It's a very, very important habit. So I have done, we are done with the section A. After this, you know, the section B will start, and the section B of this paper we will do in another video. Soon I will upload that video also. You will be able to find in the same playlist. You will be able to find the section B of this paper. I will do it in another video. So today we have done May-June 2017 Physics 5054 2-2 paper. We have done only section A of this paper in this video, in this session. So it's a great blessing for me to teach you online. If you find this video helpful, if you think that this video has made some physics concept clear to you, don't forget to subscribe my channel. Also share the link of this video onto your Facebook, into your Instagram accounts, and onto your Twitter accounts, because this will help me to promote my channel. So thank you very much, everybody. Have a good day. and God bless you all.